Alrighty. Um, so welcome to what I call OST Bootcamp, my way. If you're watching this video, it's because you are a student um, that really does want to pass this OST. Um, that 80% of students fail, and so you're doing what you have to do to try your very best to try to pass. And so this is kind of me um, simulating what I would do if I were a student inside of my class taking the geometry OST this year, right? Um, the first step is to recognize, know, and understand that 80% of students fail, 20% pass. And so, with that comes the reality that we have is that we need to be strategic about the way that we are going to go about this test. That we are going to do exactly what we need to do to just get a passing score, and that's it. Um, and so, keep in mind that there are two parts to this test, part one and part two. Today we'll be talking about part one. The first thing that I would do if I were a student taking part one of the OST is count how many total questions you have on the test. So I would click all the way to the very end and find that there are 21 total questions. Um, I also know that because my teacher told me that I need a 40% to pass this geometry OST. So if I go on ahead and inside of a calculator, take 40%, let's find percent. Uh, okay, well, let's just put this in a handheld calculator. 40% of 21 is going to give me an 8.4. I really hate that I can't find that inside of here. Let me just mess around with this a little bit. 40%. It's easier on a computer. It's much harder on an iPad that I'm working on. But if you take 40% of 21, that's around 8 questions that you need to get correct on this part of the OST in order to pass it. Just 8 questions out of 21, and you get a 40%. We're going to strive for 8 to 10-ish questions in case part two is like impossible to do. So you always want to strive for like a little bit more questions than the bare minimum, just in case part two is harder or whatever the case may be. But then I would also write all the question numbers, so 1 through 21. So as you can see, I wrote 1, 2, 3, 4, all the way to 21. And so as I go through this OST, I'm going to be essentially giving the question either a check mark or a, ooh, I had no idea how to do that type of thing, just to keep track of, how many total questions I'm like extremely 90% confident with, and I can count that as, oh, okay, that's progress towards my 8 to 10-ish questions that I need to get on this OST. So without further ado, I will go through these questions. One by one, 21, and see if, you can get these questions correct just like me or incorrect just like me, and things like that, okay? Remember, the goal is to get 40%. So here's the first question. This OST was from the spring 2017, so this is one of the very first OSTs that they have given the state of Ohio. And so this first question asks, triangle ABC is shown. Well, clearly there's a triangle ABC. It says, which three-dimensional figure, keyword three-dimensional figure, results from rotating the triangle 360 degrees about the line segment AC. So line segment AC is this line right over here. So I need to basically take a two-dimensional shape and rotate it to create a three-dimensional shape. This is a skill that we learned in Unit 8, Volume, specifically the final 2 lessons where we were rotating about some line, this, that, and the third. This is what I consider an easy question, that if you see something like this, you should immediately get it. So if you don't, just keep that in mind. But we have 4 options: cone, cylinder, pyramid, and sphere. Definitely, if I rotate this 360 degrees about that line, I will not get a sphere or a pyramid. Neither will I get a cylinder, because a cylinder would be if I had a rectangle-ish kind of sort of thing. So this answer is going to be a cone. And that looks like half of a cone, if you visualize it some way, somehow. Okay. So then I would check mark that I got question number 1 correct. I'm 90% confident with that answer. All right, question number 2. It says line segment AB has endpoints here and there. Point C is right there. The question is asking you what is the ratio of AC over CB, ratio being a fraction. Hopefully you recognize that you would have to use the distance formula to calculate the distance between these 2 points, and then whatever the distance between AC is, I will put at the top of my fraction. Whatever the distance between CB is, I will put at the bottom of my fraction. And so let us go on ahead and do that. Distance formula is one of the formulas that you do not have to memorize on the OST. They give this formula to you on it. You just have to find it. Either way, we label our points x1, y1 and x2, y2. And again, remind yourself what distance formula is. It is x2 minus x1, or 0 minus a negative 1.5 squared, plus y2 minus y1, or 2 minus 0 squared. I would highly recommend you put all of this into decimals to get an answer. So let's go on ahead and switch on over to decimals. And let's put in our little equation. So distance, again, was x2 minus x1. Those first numbers were 0 minus a negative 1.5. So 0 minus parentheses negative 1.5, close that parentheses, squared, plus another parentheses, I think it was 2 minus 0. Yeah, 2 minus 0, and that's squared. That is 2.5. So 2.5 is the number that's going to go at the top of my fraction. Now I need to calculate the distance between C and B. So I'm going to get rid of my x2, y1s, and I have a brand new x1, y1, because C is my first letter, so it's going to have the x1, y1, and B is my second letter. I will keep that as x2, y2. Applying the distance formula says x2 minus x1, so 4.5 minus 0 squared, plus y2 minus y1, or 8 minus 2 squared. Put this inside of the calculator. The first number is 4.5 minus 0. So 4.5 minus 0, or you can just put 4.5. And then 8 minus 2, which is 6, 7.5. Okay. That's the number that's going to go to the bottom of my fraction. And boom, I have my answer. Easy question. I labeled it as medium because it does require you to use the formula and things like that. But either way, we go back over here. We do a little check mark for number 2. And look at that. We already have 2 questions. We really only need 8 minus 2. 6 questions more, and we pass part 1 of the OST. Oh me, oh my. Let's continue. You can look at the rationale behind the answer to the question if you really want to. You need any equivalent ratio that equals 0.33, and this equals 0.33 if you put it in a calculator. You can also simplify your fraction if you really wanted to, yada, yada, yada. Question number 3, triangle XYZ is shown. Which triangle must be similar? Look at that word similar. You would notice that we've never talked about similarity in my class. That is because I skipped that lesson, that unit. It's supposed to be unit 6, but I skipped it because it barely shows on OST. But in this case, it does show. And so that's why I put never did. We never did this in class. That's why I categorized it as a hard question. This would be a question where you take a very smart, educated guess. So if I were a student in my class, the very first thing that I would do is find the angle, the missing angle right over here. I know that all the angles inside of a triangle add to 180 degrees. So to find this missing angle, I'm going to take my 180 degrees and subtract 100 and subtract 40. I'll find that to be 40 degrees, and boom. So this is a triangle where two angles equal 40 degrees and one angle equals 100 degrees. So if I use, a smart, educated guess, a triangle, let's look at A. It says a triangle with two angles that measure 40 degrees. I don't know. This is a triangle that with two angles that measure 40 degrees. This would be my educated guess. And if I were to take this educated guess, I would find that my answer is absolutely correct. And voila, number 3 is done. Moving on to 4. Oh my goodness. Without even reading the question, look, I have to type in a worded answer. Basically typing in an essay inside of math. Have we ever done this in class? The answer is no. This is a question that I would not even look at. I would completely skip this question. And question number 4, I got incorrect. So far I have 3 out of 8 questions. Moving on. Not even going to worry about that question, because we can afford to, as you'll see. Question 5, it says a globe has a diameter of 12 inches. It fits inside a cube-shaped box that has a side length of 12 inches. What is the volume? Volume. We're talking about Unit A, where we talked about volume. Luckily for us, they give us all of the formulas to calculate volume of these shapes. A globe is in the shape of a sphere. And so if I have a sphere, and they told me that the diameter, the entire thing is 12 inches, what does that mean about my radius? That means that my radius is half of 12, which is 6 inches. To calculate volume of a sphere, that's 4/3 pi r cubed. In this case, it's 4/3 pi 6 cubed. And let us go on ahead and find the volume of this sphere. So I have 4/3 pi 3 or 6, 6 cubed to the third. And I find my answer to be 904.778. Okay, they want us to round to the nearest hundreds at the very end. So I'm going to go ahead and put 904.778. I'm going to put 3 numbers after the decimal instead of 2, just because it makes rounding a little bit easier at the very end. And there's that. I should also probably find the volume of this cube-shaped box, which the volume of a cube-shaped box is the same formula to calculate the volume of a square prism, which is simply length times width times height, or in this case 12 times 12 times 12, which inside of a calculator, 12 times 12 times 12 is going to give us 1728. Okay. And so the final question is asking you to find the volume of the space inside of the box that's not taken up by the globe. So what we have to do with these two numbers is simply subtract them. 1728 minus 904.778 is going to give us our answer. 1728 minus 904.778 is going to give me a final answer of 823.22, and that is, of course, rounded to the nearest hundreds, and that's right there is my final answer. I'm pretty confident with my answer. I'm going to go ahead and check mark question number 5 and count it towards 1 that I'm pretty good at. As you can see on the OST, they're not as picky as I am. However, I've shown you guys how to be extremely precise with your math. They would take any value between 822.857 and 823.68 inclusive. So if you get a number anywhere near this, they would give you the point. But I like precision and accuracy. Question 6. Triangle ABC is shown. Triangle A prime, B prime, C prime is created by dilating. Ooh, we've never done dilations before. So it would be justifiable if you had skipped this question. However, if you are a high achieving student, you would know that dilations is just making things bigger or smaller. You would just multiply by the scale factor, and luckily they have given us a scale factor of 4. They're asking us for the length of line segment A prime, B prime. So we have the original A line segment AB. I need to find how long that side is. And then all I need to do is, once I find how long AB is, I multiply by 4. And voila, I have my answer. So there's 2 ways that you can find the distance between AB. First and foremost, you can use the distance formula, the very long way. Or you can recognize that this right here forms a right angle or triangle, where this side is 1, 2, 3, 4. This side is 1, 2, 3. And if you recognize this type of right triangle, you would know that this is a 3, 4, 5 right triangle. Or if you don't recognize it, you can simply do 3 squared plus 4 squared equals c squared. You'll find 9 plus 16 to be equal to c squared. 25 equals c squared. And the square root of 25 is 5. And so then, again, all you need to do is take this 5 and multiply by the scale factor to find that your new length of AB is 20 units. I'm pretty confident with my answer to question number 6 that although we never did it, I can use the idea of dilations, which is just multiplying by the scale factor. And so that's why I've categorized this question as an easy one. Let's go ahead and mark this question number 6 as done. And move on to question number 7. A study reports that in 2010, the population of the United States was 308 million people, and land area was approximately 3 million. Based on the study, what was the population density? Oh, there's that word density. Hopefully it makes you think about Unit 8 volume, the specific lesson that we had about density. And they want us to put this in people per square mile. So this is a fraction where people is going to go at the top of the fraction and square miles is going to go at the bottom of the fraction. Again, how many total people do we have inside of this problem? We have 308 million people. And how many square miles do we have in this problem? We have 3.5 million square miles. So if I put this into a fraction, I have 308, 745, 538 people per 3,531,905 square miles. Let's put all of this inside of a calculator. Again, a Desmos calculator. However, for convenience and to save time, I'm using my own handheld calculator. Ha ha he he. No, you can't use it. 3, 531, 905. I get, and we want to round our answer to the nearest tenth, meaning one number after the decimal. We get 87.4 as a final answer. I'm pretty confident with this question, and so I'm going to go ahead and mark question number 7 as correct. So look at this already. I don't know how long we are into this video, but we have 6 questions that we are very confident with. We only need 8 to 10. So far it's looking pretty good for us. And I just hope that this is exactly how it is on your OST this year. Question number 8. It says a figure is fully contained in quadrant 2. The figure is transformed as shown. A reflection over the x-axis, a reflection over the line y equals x, and a 90 degrees counterclockwise rotation about the origin. In which quadrant does the resulting image lie? First and foremost, identify transformed. We're talking about Unit 3, congruence transformations. When we were flipping triangles, can we move it up, down, left, right? Can we rotate it? Can we have symmetry with it? All that fun stuff. let's go on ahead and draw a coordinate plane, and then let's label our quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4 right over there. Again, it says a figure is fully contained in quadrant 2. So perhaps we have a triangle, yeah, in quadrant 2. And then we reflect it over the x-axis, which we know is this horizontal line. If I flip this triangle over the x-axis, my triangle now looks something like this. So that's done. A reflection over the line y equals x. Hopefully you know what the line y equals x is. It's this line right over here. So if I take this second triangle and flip it over this line, my triangle will look something like this. So that's done. So we're still in quadrant 3. And then finally, we took this last triangle and rotated 90 degrees counterclockwise. So not the way that a clock goes, but this way. When I do that rotation, my triangle ends up right over here somewhere. And so that final bullet point is done, and the last location of this triangle has to be quadrant 4, and this question is done. I'm pretty confident with the question, and so I'm going to go ahead and check mark that guy. Question number 9. Again, hopefully you're going through these questions with me. I know I go pretty quickly. You know, they're asking for percents and things like this. If you read through this question, you'll realize that we've never really done this type of question. I've marked this as a hard question just because the answer to the question was pretty complicated. I'm going to go ahead and say, skip this question. We're pretty confident with the rest of this. I'm not going to waste any time. And I want to save my energy, you know. Let's go straight to 10. Hopefully this looks familiar to you. Got you guys on the tests because you were confused about this third number. Says quadrilateral ABC is inscribed. So inscribed, we're talking about unit 7 when we talked about circles and inscribed angles and quadrilaterals. And we want to find the value of y, this angle. We should know that opposite angles, so these two angles, are supplementary, meaning that these two angles have to add to 180 degrees. So 83 plus something has to equal 180. I subtract 83 on both sides, and I find that y equals 180 minus 83, and that answer is 97 degrees, and that's my final answer. Question number 10 is done. Question 11. Alright, so the question is asking you for the complement of the event. Hopefully you paid attention in class. You would know that the complement is basically the opposite of something happening. And when we read the question, we have that he draws a red piece of candy. So he has red pieces of candy and he has blue pieces of candy. So the opposite of him getting a red piece of candy is he gets a blue piece of candy. Oh my goodness. This is Unit 9 probability. This is a very easy question. Hopefully you get it on the OST. Most likely not. But question number 11 is done. We are speeding through this. Hopefully you're catching up. Question 12. A rhombus. We've never talked about rhombuses. But we have talked about this idea that is inside of this question. Getting thirsty here. It says rhombus PQRS is shown on the coordinate plane. Points M and N are midpoints. Select all of the transformations. There's that word transformations, meaning we're talking about Unit 3, congruence transformations, that puts this triangle exactly on top of itself. So we need to select all the answers. So this is what makes the question a medium level question, is that we have multiple answers. And so if we get one wrong, we get the entire question wrong. So let's go through each of our options and see if they make any sense. first option says a 90 degrees clockwise rotation about the center of the rhombus. So I think this right here is the middle of the rhombus. Okay, if you don't know, this is a rhombus. And if I were to rotate this rhombus 90 degrees clockwise, my rhombus would look something like this. And that is not exactly on top of the rhombus, and so, therefore, this is not an option. I do not like this answer. It says a 180 degrees clockwise rotation. So if I were to take the thing that I just drew and rotated it another time, I would land exactly on top of the original rhombus. And so, therefore, this is one of the answers. What about a reflection across PR? So here's PR. If I were to take this triangle, yeah, and flip it over this line, I would land exactly on top of this other triangle. Same thing, that if, again, I have this line PR, that's not a straight line PR. If I flip this line PR, and I flip this triangle exactly over this line, I would get exactly this triangle. And so, therefore, this is one of the options. A reflection across NM. So here's NM. Yeah? If I were to take this and flip it over this line, my thing would look something like this, where the pointiness is kind of out there. So this is not an answer. Again, these are very visual type questions, and so you have to be really careful. A reflection across the line QS. So if I have QS right here, and if I were to take the same thing, same idea, if I were to take this triangle and flip it over this line, I would land exactly on top, so on and so forth. That is our final answer. So there are 3 total answers to this question. Again, if you don't get one of them, you get the entire thing wrong. And so we're pretty confident with question number 12. Let's go ahead and check mark it and move on to the next one. Before we move on to the next one, please notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 questions. We are for sure passing part 1 of this OST, without doubt. This is enough where you can stop and you can be good. I don't recommend that. I recommend you do every single question